Okay, so today we are finishing our last section. We're going to talk about section 3.5. It's where we talk about functions. Okay. Now this whole first page explains what a function is. I'd like to go to page 2 and start with function notation and how we'll be working with it and do this page, and then we'll come back to what a function actually is. Okay. So the function notation here is written like this, and it is read f of x. Okay, so it doesn't mean f times x, it is the function notation altogether. Alright, so in the first example, we have that f of x is equal to this line 2x minus 5. Okay. It's a line that has a slope of 2 and a y-intercept of 0, negative 5. Okay. Now what we could do is we could put various things in here, whatever we would like, and then everything else about the function will stay the same except for the variable. Okay. So like for example, if I wanted to find f of 3 instead of f of x, well, wherever I saw an x, I'd just put in a 3. And now we can just simplify this. 2 times 3 is 6, and then the minus 5. So that is f of 3 is equal to 1. Okay. We can find f of negative 4. And the function, this particular one, is 2 times x, okay, minus 5. But instead of finding f of x, we'd like to find f of negative 4. So now when we do that, when we simplify, 2 times negative 4 is negative 8, and then we still subtract off the 5, which is negative 13. So f of negative 4 is equal to negative 13. Okay. So really, this is just a matter of substitution and simplifying. Okay. But our functions can change. Okay. Say, for example, we have our function is equal to 1 minus 3x. Okay, that's fine. Okay, we have to define what a function is every time we use it. Now let's find f of 2. Okay. Now this function is 1 minus 3 times x, so wherever I see the x, since I'm going to find f of 2, I replace the x with 2. Okay. And now we can just simplify. This becomes 1 minus 6, which is negative 5. We could find another value, and it'd be 1 minus 3 times whatever value we'd like to look. So if we have a negative 1, I'll just replace the negative 1 in there. And now simplifying, 1, now minus and a minus become plus, and 3 times 1 is 3. So f of negative 1 is equal to 4. But we don't have to just find values for numbers. We could do what we call a change of variables. Okay. So instead of finding f of w, or of x, I could find f of w. Then wherever I saw the x before, I'd put the w, and then that just simplifies to 1 minus 3w. Okay. So it's the same function, I just have a different variable in here. I could also find, well, we can find truly almost anything we want. What if I wanted to find w plus 2? Well, that would mean I'd put the w plus 2 inside of here. And now I can simplify. The 1 stays. And to simplify, we're going to have to be careful because I'm going to distribute. But be careful because we're going to distribute the negative as well. So negative 3 times w is minus 3w. And then negative 3 times positive 2 is negative 6. And then we can combine the like terms. 1 minus 6 is minus 5. So minus 5 minus 3w. So f of w plus 2 is negative 5 minus 3w. And that's all there really is to it. We just have to keep our notation straight and watch our algebra. So let's do some more. Now, function notation doesn't have to just be f of. That's the most common one. But another one that's very common is g of x. Okay? It's just giving it a different name. So in this case, we've specified g of x to be x squared minus 1. Okay? Notice that I can't just write down g of x. I have to say what g of x is equal to. Alright, we've got quite a few to find here. We need to find g of negative 5, first of all. So that's going to be the function, whatever I put in for x will be squared, and then we'll minus 1. Okay. So we're finding negative 5. Now, just so we don't get confused, what will happen here, remember, negative 5 squared is negative 5 times negative 5, and then we'll still subtract off the 1. Now, the negative and negative become positive. 5 and 5 is 25, minus 1 is equal to 24. So g of negative 5 is equal to 24. G of 0, so our function is something squared minus 1. So in this case, our something is 0. Now this one's easy. 0 times 0 is just 0. And then the minus 1. So g of 0 is just minus 1. We could find our next one. Okay. Our next one involves a number and a variable. So g of 2a, we'll have to take 2a and square it, okay, and then subtract 1. So remember that's 2a times 2a minus 1. Now 2 times 2 is 4, and a times a is a squared, and then we still subtract 1. Okay. So g of 2a is 4a squared minus 1. Now that's different than if I would take g at 2 times g of a. Okay. That would mean 2 times g of a, which is 2 times, now g of a will do the change of variables here. But notice that this function has 2 terms, so anytime I'm multiplying I need to put up the brackets or the parentheses. Okay. Now inside of here, a squared is just a squared minus 1. And the reason why we put up the parentheses, remember, is because we have to distribute the 2. So this is 2a squared minus 2. So notice the difference in notation. This is 2 times g of a. This is g of 2a. So 2 different things. Okay, we could also find g of, now let's put a sum of variables in here. What if I wanted to add a and b? Well, then the form stays the same. Something squared minus 1, and our something is a plus b. Again, so we don't get ourselves confused, remember that's a plus b times a plus b, and then we'll subtract off 1. The reason why it's helpful to do that is because inside of here, now to simplify, we're going to have to FOIL. So this becomes a squared plus ab plus ba plus b squared, just foiling it out, and then we'll subtract off 1. Now remember, we want to collect like terms. These are actually like terms because a times b is the same as b times a, because multiplication commutes. So we could write this as a squared plus 2ab. We generally put the variables in alphabetical order, plus b squared, and then finally we'll minus 1. So this entire expression here is what g of a plus b equals. let's do another one. Okay. Now whatever we're putting in here, remember it's going to be that squared minus 1. So what we're putting in now is x plus 1. So x plus 1 is what's going to have to be squared. And then we can subtract off the 1. Now remember, here we'll FOIL. So this is x squared plus x plus another x plus 1. And then we subtract off 1. Now combining like terms, x squared will stay. X plus x is 2 x's. And then 1 minus 1 is 0. So g of x plus 1 is just x squared plus 2x. We could find something that's very similar to g of x, something squared minus 1. We could find g of negative x. So in this case, the negative x is what's going to get squared. So remember, that's negative x times negative x, and then we'll subtract off 1. Now here, negative and negative become positive, and x times x is x squared, and then minus 1. So g of negative x is x squared minus 1, which is exactly the same thing as g of positive x. Now that doesn't always happen, but in this case it is. Now the difference here, we could find negative g of x. Okay, so this is g of negative x, this is negative g of x. Okay. So the way I like to think about this is, remember, anytime we have a negative, we can think about it as being a negative 1, so we don't forget about what's going to happen. And then we're going to multiply that by g of x. Now, negative 1, again, we'll open up our parentheses, because g of x is x squared minus 1. So now when we distribute the negative through, what will happen is it will change the signs, and we'll get negative x squared plus 1. Okay? So this is like negative 1 times x squared. Now, a substitution that happens a lot, let's switch functions now. Let's say f of x is equal to 5x plus 6. A substitution that we'll find a lot is that we'll find not just x, we're going to find x plus h. So the form of this function is 5 times x plus h plus 6. Right? I should put this in a different color, x plus h. So that goes in wherever we see the x plus h. And now we can simplify. We have to distribute the 5 through, which will give us 5x's plus 5h's, and then the plus 6 will also come along. So f of x plus h in this case is 5x plus 5h plus 6. And then sometimes what we want to do is we want to find f of x plus h and then subtract off our original function f of x. Alright, well, we know what f of x plus h is. It's this. So we'll take 5x's plus 5h's plus 6. Now here we'll take a subtraction, and then we have to subtract off the original function. So remember, when you do this, again, we want to use parentheses, and our original function is 5x plus 6. And if you want, go ahead and put that negative 1 in front of the parentheses so you can remember. Why we're going to do that is we're going to have to subtract and change the signs. So this first part will stay the same, 5x plus 5h, plus 6, but now we're going to subtract 5x and then subtract 6 by distributing, and now we can combine like terms. 5x subtract 5x, 0, and 6 minus 6 is 0, so the only thing we're left with is 5h. Alright, so this is one we need to get very comfortable with, determining what the function evaluated at x plus h is, and then subtracting off the original function. Alright, so that's the function notation. Now, what exactly is a function? Okay. And so this is where we go back to the first page. A function is simply a rule. Okay. And what it'll do is it'll give you exactly one output for one input. So notice here on the last pages that we did, in all of these, we were able to evaluate functions, this function, at various different values. Okay, so these are the inputs, whatever. And then whatever came out is known as the output. Okay. And every time I did it with the function values, there was only one output. Now it might have multiple terms, but there wasn't, say, plus or minus this amount. There was just one output. All right. So sometimes people draw it with a box. Okay. So and this box is representing that rule. Okay. So with this diagram, I'm putting 5. This is my input. It'll go through that rule. We'll do the manipulation, and what comes out is 10. There's only one output there. Now, what would not be a function is, say, like if you put 25 in, it goes through the rule, and when you're done, what comes out is plus or minus 5. This is two different values, so this is not a function. But it's often really difficult, or not difficult, but tedious to draw a box, and it doesn't tell us a lot. Another thing that some people call a rule is it's also a map. A function is a map. Okay, so, and by a map they mean this: if I put a in and it goes through the rule, what comes out is 1. If I put b in, it goes through the rule, what comes out is 2. If I put c in, what comes out is 3. Okay. So in this diagram, every input goes to one output. So yes, this is a function. Now here's another diagram. These arrows represent the rule. And in this case, A goes to 1 and A goes to 2. So that is this situation where I put in one thing and out comes 2 different. So this is not a function. And they don't always have to be lined up nicely, like in this one, A goes to 1, now B goes to 3, C goes to 2. So the arrows cross. It doesn't really mean anything other than we'll just have to look. Does B only go one place? Yes. Does C only go one place? Yes. Does A only go one place? Yes. So this is a function. Here's another diagram. Okay. Here we have A going to 1, and B going to 1, and C going to 2. So we might be tempted to say that this is not a function. But again, just asking ourselves, does A go to a single value? Yes. Does B go to a single value? Yes. Okay. It's not like this one where A goes to 1 and to 2. Okay. So this is also a function. So we could also put rules into words. Let's consider this if we had every person in the classroom assigned to their siblings. Okay. Well, I'll just do a diagram for me. Right. I have 3 siblings. Okay. There's Tom, there's Mary, and there's Joe. Okay. So, and then we could think about all the other students. And so some students might only have 1 sibling. So student 1 might have 1 sibling. What should we call them? Bob. Why not? Something simple. And then we could have a second student. Let's just call them S2. They might have 2 siblings. Okay, Jack and Jill. Something like this. Okay. So now this grouping over here is the inputs. And if we look at it this way, and this range is the outputs. Okay, so I'm in the classroom, there are 3 siblings. Student 1 is in the classroom with 1 sibling, and student 2 is in there with 2 siblings. Okay. So from here, we can see that this is not a function. We're in this same case, where it's called an element in the domain, goes to, in this case, 3 elements in the range. Okay. I'll define domain and range here in a minute. So this is not a function. Now, on the other hand, if we tried to assign each person in the classroom, we'll do the same thing. We'll say me and student 1 and student 2. Now, if I'm assigning to each person in the classroom the number of siblings they have, well, then I am assigned to the number 3, because I have 3 siblings. Student 1 is assigned to the number 1, because they have 1 sibling, and student 2 is assigned to the number 2. So in this way, by changing what we are assigning them to instead of their names, but the number of siblings, now this is a function. Okay. So some language that we need then, you've heard me use this word, you will need to know these. These will need to go in your flashcard. The domain of a function is the set of all inputs. Okay, so we could call this one the domain. Okay. And the range is the set of all outputs. Okay. So other terminology. Okay, the domain is the set of all inputs. This is also called the independent variable. This is usually the x's. This is how we think about it. The range is the set of all outputs, which is also the dependent variable. And we usually think of these as the y's. Okay. And now that we know about functions, it'll be the result of f of x. Okay, the output. Okay. That is what f of x equals. Okay. So let's see here. A certain function assigns each state to its capital. Well, what is the domain here? And what is the range? Okay. So here we assigned each person in this classroom, me, student 1, and student 2. We said these were the inputs. To their siblings, okay, and those are the outputs. So we're going to assign to each state, so that means the state is the domain, its capital. Okay. Okay. And then they ask us, just what we've done up here, if we consider again the function that assigns each person in this classroom to the number of siblings they have, what is the domain and what is the range? Well, we then said the people in the classroom got assigned to what? Well, to the numbers, okay, to the number of siblings. B-L-I-N-G, siblings. Okay. Alright, so that's just a little introduction to what a function is. I hope this makes more sense We care about what goes in, we care about what comes out. These are given specific names, domain, and range. There is the rules that we assign. Each input can only go to one output, so in this case, this is not a function. Okay. And, okay, we did that, so I think that will get you through your homework. These are more mappings for you to decide if they are functions or not. Assign. It's perimeter, yep. And then they give you some different functions that you'll need to evaluate. Okay. Alright, let me know if you have any questions. Send me an email.